Activity 6 of having fun with chemical reactions. In this section we're going to look at how do we test for acids and bases. But before we go on to the testing, let's firstly find out what acids and bases really are. Now an acid is basically a substance which contains a large quantity of hydrogen ions or H plus ions. This means they've lost one electron. Because they've lost one electron, they become positively charged. As a result, they have the charge +1. Now, in the laboratory, there are four main acids that we use: hydrochloric acid, nitric acid, sulfuric acid, and carbonic acid. They have the following formulas: HCl, HNO3, H2SO4, and H2CO3. It is important as part of your study that you actually learn these formulae for each of the acids. If these become common knowledge, when you're doing assessment tasks, life will become very easy, and especially when you're starting to write formulae and equations for the acid-base reactions. One thing also worth noting is that the concentrations of acid are determined by the number of hydrogen ions that you've got. If you have a large quantity of hydrogen ions in your solution, then we say that your acid is concentrated. As a result, your concentrated acid will be highly reactive. However, if you add a large quantity of water to your acid, the number of hydrogen ions per volume of water will decrease. As a result, it will become diluted. It will become a very weak acid, and as a result, all reactions will take place very, very slowly. Well, the opposite of an acid is a base. Now, basically, a base is a substance which contains negative ions. Now, the main bases that we have are hydroxide ions, or OH minus ions, or oxide ions, O2 minus ions. Now, what we need to notice is that they are negatively charged. Now, when they are dissolved in water, they become a base or an alkali. Now, the main bases that we might have can be seen here. For example, magnesium oxide, MgO, potassium oxide, K2O, ammonium oxide, brackets NH4, close brackets 2O. That means that the thing in brackets, the NH4 is the ammonium ion, and we've got two lots of them which are joined to one oxygen atom. Also, we've got hydroxides. We've got magnesium hydroxide, Mg brackets OH close brackets 2, potassium hydroxide, KOH, and ammonium hydroxide, NH4OH. Remember, the OH has a 1 minus ion, and we treat it as OH on its own. Again, the formation of these formulas need to be learned. Now, you can go back and look at the chemical skills course, and this will help you through all your chemical formulas if you're having trouble at the moment. So enroll on that, run through the chemical formula sections, and you'll be okay. Okay, so what we've done for you here is we've put together a practical video to show you how do we test for acids and alkalis. Now, these are not definitive with respect to indicators, but they're the ones that we use at St Hilda's. Now, the main indicators that we'll be using here are bromothymol blue, red litmus, blue litmus, methyl orange, phenolphthalein, and universal indicator. Now, during the practical video, what I'd like you to do is use the Activity 6 worksheet and fill in the colours that you see during the practical for both acid and base. Now, the neutral is what it looks like prior to being added to the acid and base. So that way you get an indication as to what colour it changes to and what colour it changes from. Also note that there are such things as negative tests where they don't react at all. These things are important to know because if it's a negative test, it means that it's not likely to be one where it's positive. Now, this will make more sense when you watch the video. Okay, now there is another way of testing for acids and bases, and that's using universal indicator. And another good thing about universal indicator is it can tell us the strength of the acids and base that we have. Now, you will have studied this in class, but universal indicator will change colour according to the strength, and as a result a scale is set up. And it's a colour scale. That's the sort of scale that you might use if you're looking at a swimming pool. If you're testing the water for chlorine in a swimming pool, you will be looking down the latter end of the pH scale, from round about 1 to 6. You may use the alkali base if you've got a spa and you're looking at the alkalinity within that spa. As a result, by adding various chemicals, you can change the pH. Now, at this stage, what we need to know is, what are the various areas of the pH scale? Well, the middle section, the green section, is neutral, pH 7. That's basically what water is. Acids will run from 1 to 7, with 1 being very strong acid and 6 being very, very weak. And bases will run from 8 to round about 14, going from a blue to a purple colour. 14 being the most alkaline. These are the sorts of things that you'll find in oven cleaner. As I stated, neutral is green, round about 7. And you'll see after looking at the video that universal indicator comes out green straight out of the bottle because it's mixed with water. So have a look at the video, read through the information that we've got here, and have a go at the exercises after the video. Thanks for watching, and see you soon.